Now we are first discussing about nomenclature of hydrocarbon, and then we are proceeding for functional group. Let us check out first nomenclature of hydrocarbon. We are not going in detail, but to certain level we are going at depth. For example, there are various technique of giving name. Usually in old days, when this chemistry was not that developed, certain chemicals were named. For example, acetylene was there, or what we are saying, butane, isobutane. In case of pentane, it is pentane, neopentane, isopentane, like that. Names were given. Say for example, if I am showing here that now you are aware that all these carbon atoms, their 5 valencies are satisfied by 4 sides. So you are aware now that if I am drawing only this much structure, then also you should aware that rest of the valencies are satisfied by carbon, by hydrogen. So this is pentane because 5 carbon members are there. So as 5 carbon members are there, they are pentane. Now here, and say this is also pentane because 5 carbon are there. Number of hydrogens are same. Here also count number of hydrogen here, as it is pentane, it should be 12 hydrogen and 5 carbon. So there are 5 carbon, number of hydrogen 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can check out here, you will get same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 hydrogen. So their molecular formula is same, but the structural formula is different. In this case, we are calling isomerism. What is isomerism? When two chemicals, particularly here in case of organic chemistry, the two chemicals are having same molecular formula. Here also molecular formula is C5H12 in both the cases. So they have same molecular formula but different structural formula. They are called as isomers of each other. Here if I am drawing this 5 structure like this, rest of the valencies are satisfied by hydrogen. So just check out, as 4 carbon atoms are bearing out hydrogen, 4 3s are 12. So 12 hydrogen and 5 carbon. So this is also having same molecular formula but structure is here different. So this is called as pentane, this is called as isopentane. Whether carbon is here or here, it is same. So this is isopentane and this is called as neopentane. So these are isomers of pentane. Like that, complications may arrive if number of carbon atom increase more. Say for example, here I am decreasing out number of carbon atom. There are 4 carbon. You are aware that is called as butane. There is only one possible thing. This is the possible thing. So this is butane, this is isobutane. But here pentane, isopentane, neopentane. So suppose hexane is there, you will get still more. But here pentane, instead of this butane, we have suppose propane. Then for propane only 3. So there is no chance of any other isomerism. So for this purpose, you are getting, as number of carbon atom increases, the number of isomer increases, and therefore it is difficult to name only under category of pentane or hexane, heptane, like that, because as number increases, the possibility of isomerism also increases. And for that purpose, we have now nomenclature that is called as IUPSC nomenclature, that is International Union of Pure and Applied Chemistry. So that is called as IUPSC nomenclature. I am writing here name IUPAC. What is called as International Union of Pure and Applied Chemistry. Now according to IUPSC nomenclature, the first thing, we have to select longest chain. So here I am naming first. This is called as pentane. This is called as isopentane, and this is called as neopentane. Now, what is first thing? That we have to select longest chain. Now, what IUPSC nomenclature says? Select longest chain. So here there is only one longest chain. So select that longest chain and name. So it is pentane as it is. Now in this case, select longest chain. Now longest chain I can go by this way, 4. I can go by 1, 2, 3, 4. I can go by 1, 2, 3. No. There are 4 members, so 3 member chain is small. So I can select the longest chain as this. Now this is called as branch. We have to number in such a way that branch should get minimum number. Suppose I am numbering here 1, 2, 3, then branch is getting 3 number. But suppose I am numbering from here 1, 2, then branch is getting 2 number. So I had to name here as number here as 1, 2, 3, 4 like that. Now as it is 4 member, I had to write name as butane. Alright. Now check out the third position, there is a branch. This group we have to name. Now you are aware CH4. This is called as methane. Whereas here it is CH3 and one valency is not satisfied, suppose. So it is satisfied over here. So this CH3 and dash, this is called as methyl. Say this is methane, this is methyl. Now here this is called as alkane. This is called as alkyl. So this is alkyl group. Now here it is butane. So parent chain having 4 numbers, so we are writing it as butane. Now on second position it is methyl group. So I am writing here 2 methyl butane. So this is not isopentane now, this is 2 methyl butane. So this way we are giving IUPSC name over here. So it is 2 methyl butane in this way. Now same way we are trying over here. Select longest chain 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Anyway you can go, you are having number 3. So select longest chain. Now number from any side 1, 2. So on second position 1, 2 on second position. So number from anyway, I am numbering now from left to right. So it is 1, 2, 3. So we are giving name here 3 chain. That means we have to give name as propane. So I am giving here name as propane. Now on second position this group is there methyl and this group is also methyl. So I have to write here 2 di, because 2 methyls are there, methyl propane. So this way the name is not neopentane, it becomes now 2,2-dimethyl propane. So like that the names are given. While giving name, the prefix means the word we are adding previously, previous to the word, that di, tri, tetra, like that prefix are there, mono. So these type of prefix are not considered as name. So when we are choosing alphabetically, we have to select it from methyl M, ethyl E, like that, and not di and tri, etc. So like that simple rules are there. We are going to that level only for nomenclature. Now here this is propane, this is butane. We are calling this as isobutane. Try to recollect mixture of butane and isobutane. That is called as LPG. Under a little bit pressure that becomes liquidified and we are using at home that as liquefied petroleum gas, that is gas cylinder we are using. Now here this is isobutane, but according to our nomenclature it is 1, 2, 3 propane. So I should name this as propane, whereas this group is methyl group on second position, so it should be 2-methyl propane. So this is the basic idea of IUPSC nomenclature. We are not going in detail. Now in case of alkene, all rules are same, but priority should be given to double bond. Let us check out. Now here purposefully I am writing here Now you have to consider rest of the valencies are satisfied by hydrogen. So this is the chain. I can select out this is at chain or this is at chain. No problem. Any chain that is longest chain having member 4 and 4, 8. Suppose I am going this way 1, 2, 3, 4, 5, 6, 7, 8. This way also 8. So you are aware as 8 is there, it should be as double bond present octene. Now numbering, I can number from 1, 2, 3, 4 like that, or I can number from 1, 2, 3, 4 like that. Here branch is getting number 3, but if I am writing from here, then branch is getting number 6. So according to alkane, suppose it is alkane, then I should number from this side. But as it is alkene, I have to give priority to double bond, and double bond should get minimum number. So here numbering is in this way 1, 2, 3, 4, 5, 6, 7, 8. And so I have to write name on this position 2 member, that means ethane. So this is ethyl, methane, methyl, ethane, ethyl. So this is ethyl at what position? 6. So it is 6 ethyl. Now name octene. So oct, position of double bond is 2. You may say 3 also, but minimum number is 2. So octuene. So this way we have to name alkene. Now suppose here is triple bond, then rule is same. Triple bond should get minimum number and the name should be everything same, but instead of ENE it should be YNE. So this way IUPSC names are there. What is the benefit of this type of IUPSC number? That by getting name you can construct the structure of compound. That is the important thing. Or if only compound molecular formula is there, then whatever you are following rule, you can construct the name of compound. So that is the best technique that we can remember tremendous amount of organic chemicals. This is just superficial knowledge about IUPSC nomenclature of hydrocarbon. We are not going in detail. Particularly this is about open chain. In case of closed chain, cyclo prefix is added for alkane. Rest of the things are same. Whereas in case of organic compound, any position should be considered as 1. Okay. But suppose here OH group is attached, that means phenol, or like that hetero group is attached over here, then we are considering numbering like this, the 1, 2, 3, 4, 5, like that. Now we are switching to another topic. Say we are just getting superficial knowledge of IUPSC, not at depth, because we not describe about here organic chemical like aromatic compounds and all that. But now we are focusing more towards functional group. Now when organic compounds are there, they are consisting of hydrogen and carbon. We are calling that as hydrocarbon. But apart from hydrogen and carbon, something else is entering over there, then we have to account for that also. Other atoms, they are coming there in organic compound. They are hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, certain metals, all these compounds, elements, they are entering here. For example, you are aware of hemoglobin. Now hemoglobin, that is present in blood and carries oxygen, that is compound where apart from carbon, hydrogen, oxygen and nitrogen, there is presence of iron also. So this way we are getting certain metals, they are also involved over there. In case of chlorophyll, you are aware, because of that chlorophyll, green plants are green. So this chlorophyll, that is also having metal atom, that is magnesium. So apart from carbon, hydrogen, oxygen and nitrogen, there is presence of magnesium atom also. So like that, various compounds are there. We have to now account some of these compounds, and for that purpose we are calling the thing as functional group. Let us check out certain facts involved before we are going to discuss about this functional group. Say for example, when we are discussing history of Russia, we are saying that there is Russian revolution, particularly Bolshevik revolution or communist revolution. We are saying these revolutions are carried out by not all people but fewer people in the country. For example, the Bolshevik revolution, according to some knowledge what I have, some 25,000 people were involved in revolution, whereas population of Russia at that time was more than 10 crore, and still only 25,000 people, they carried out revolution in the nation. So they are called as functional with respect to revolution. Say scientific research in case of USA, America, we are saying Americans are going on moon. Okay, but practically speaking, only 3 Americans were there in initial first stage. They reached till moon. Out of that, 2 landed on moon. The third one was there in Eagle. That was the another spacecraft which was revolving around moon at that time. But what we are saying, Americans are there on moon. So it is not that all 25 crore Americans were on moon. So this way, functional thing we have to consider. Now same way, suppose I am showing structure. You are now aware of this type of long chains. C. If other thing is not there, I should call this as 3 plus 3, 6, 1, 7, heptane. But if I am attaching here OH group, then suddenly properties of this heptane change out. Now this is called as alcohol, as OH group is attached and reactions are carried out with respect to this part. Rest of the part becomes stagnant. Stagnant means they are not taking part in reaction. So chemically this part is inactive. Only this part usually undergoes reaction, and therefore this part is called as functional group. Now you are aware, the first functional group we are going to discuss here, say methane is there, -1 hydrogen, we are getting 1 vacancy. So here hydrogen is moving out, so remaining hydrogen 3. This is called as methyl. So simply I should say this is alkane, this is called as alkyl. So we are replacing suffix as ane to yl. So this way methane, methyl. Then same way C2H6. You are aware this is ethane, ane. This should replace ethyl. So this way we are having first functional group, that is alkyl group. In chemistry we are representing this group by letter R, and dash is there in front of R. So this is called as alkyl group. So keep in mind this way, this is alkyl group, it is represented by R and dash. Now the first functional group we are going to discuss here, that alkyl group we discuss. Now we are attaching this to various other groups, the confusing and non-confusing. So here I am first giving you simple group, only OH is attached. So this is called as ROH, that is alcohol group. So we can keep in mind, if R and OH is there, we are calling this group as alcohol. So you can write the name. It's very simple to use pronouns, that is alcohol. You are aware that when we are talking of liquor, that means rum, wine, whiskey, or any name of this liquor, it is having active ingredient, that is ethyl alcohol, or it is simply called as ethanol. So this way, this is there, or even in spirit, this is active ingredient as ethyl alcohol. Now, second functional group, okay, how to remember this? So R can be anything like CH3OH. So you are aware this is group called as methyl, this is called as alcohol. So I should write this as methyl alcohol. Don't consider that OH group is acidic, basic or neutral. Keep in mind, it depends upon the substance attached to OH group. Alcohols are neutral in nature. Okay, many students are having concept that NaOH is basic in nature, KOH is basic in nature, therefore alcohol should be basic in nature. But no, when we are going to discuss certain other facts in inorganic chemistry, we are discussing the nature of OH group. But right now you can consider here, in this case, it is not OH is responsible, the substance which is attached to OH, that determines where this is acidic, basic or neutral. So here it is methyl alcohol, it is not acidic and not basic, so it is neutral. Now same way C2H5OH. As it is C2H5, you are aware this is named as ethyl, and then this is alcohol. So like that, parent alkane, we have to name parent alkane, then replace ANE by YL and say alcohol. But this method is also now called as traditional method of naming. In case of IUPSC, this system is replaced. Say this is methyl, I have to write name same as methane. For alcohol, I have to use suffix as OL. So I am replacing out last E. So methane first write, replace last E by ol. So this indicate this is alcohol. So what is name of this now? Methanol. Same way here, what we have to do? Write down name ethane. Okay. Now replace E by letter ol. So this is ethanol. Suppose long chain is there, that C, 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 and OH group is here. Say I am adding out one more C. Then we have to number in such a way that OH group should get minimum number. So here 1, 2, 3, here 1, 2, 3, 4. So minimum number 3, but total number of member 3 plus 3, 6. Suppose any other chain is there, then we have to select the chain bearing OH group. That is important, not longest chain. Longest chain bearing OH group is important. Now here I am going superficially only. So 3 plus 3, 6. So it is 6, so it is hexane. So name should be hexanol. But no, we have to give position of OH group also. So here it is position is 3. So this is named as hexane. What we have to do? Replace last E. Now put dash. Put 3. Why? Because it indicates position of OH group. And then put ol. So this is hexane 3 ol. Why not I have used here? Because methyl group, anyway you can place, it is methane 1 ol. So this name actually should be, according to this system, methane 1 ol. But when it is 1, it is not required to write down, and therefore this is not correct, this is correct. Same way for ethyl group, OH group can be, say this is ethane. Either here or here, it should get minimum position, so it is getting number 1, and therefore it is not ethane 1 ol, it should be ethanol. But in case of propanol, the third member, there is chance that propane 1-ol or propane 2-ol. So like that numbering system is there. This is about alcohol. So this is first functional group. Apart from R we discuss, that is alcohol group, OH group. So you are aware, this is R, OH. We discuss this is alcohol. Now it is R, C. I should write here only. It is resembling to this only, ROH. This is also R, C is part of R only and OH. But no, we are taking C outside and this entire is considered as functional group. You can place H instead of R also, or CH3, etc. Now this type of group we are calling as aldehyde. So this is aldehyde group, that RC double bond OH. The first member of this is HC double bond OH. So here this R is replaced by H. Now it is having name as formaldehyde. Suppose this is replaced by CH3, R is replaced by CH3, we are getting RC double bond OH. Now here two members are there, it is named as acetaldehyde and so on. So this type of compounds, they are called as aldehyde. This is formaldehyde, this is acetaldehyde. But IUPSC nomenclature is not allowing this type of name. According to IUPSC nomenclature, the parent carbon we have to find out. Number of carbon is 1. So it is named as methane. 1 carbon is there. Now this is aldehyde. So I have to go by first 2 letters. So in alcohol we named as OL. Here I am writing out OL. So here we have to write down AL, small a obviously. So I have to replace now E and place there AL. Whether it is 1 aldehyde or 2 aldehyde, no question, because aldehyde group is always at end of this. So there is no necessary that mentioning position of aldehyde group, it will be at end. Now here 2 members, so name them as ethane. As it is ethane, I have to replace E and it is aldehyde, so I have to place Al. So this type of suffix we are adding. Now you will able to get idea, this is ethanol, whereas in case of alcohol it is ethanol. So here it is prefix Al, here it is suffix Al, here it is suffix Ol. Here also it is methanol, Al, Ol. So this is alcohol, whereas it is aldehyde. Why we are writing this? One important part is there. You are continuously hearing about some problem in liquor, particularly what we are calling the liquor that is made in old style, or rather than the liquor which is not made in scientific laboratory, not tested in scientific laboratory. This type of liquor usually contaminated with some poisonous material, and then you are hearing that people are dying by consuming poisonous liquor. You can observe certain disaster at least twice or thrice in year anywhere in India, because this type of liquor that is illegally prepared, that is comparatively very, very cheap, no taxes, nothing, and the most important thing, no other test, quality control and no other tests are there. And at that time certain people, they are adding out some part of poisonous material to get more and more intoxication over there. Now, what is exactly that we have to discuss? Say, alcohol is good for health or not? Those who are consuming, they are saying it is good for health, but say no, it is not good for health. But basically, alcohol is neutral. It is not, we can say directly, that good or bad for health. What is the part? That in our body there is an enzyme. That enzyme converts alcohol into aldehyde. Getting idea? Say, here this is alcohol and this is aldehyde. So when methanol is there in our, suppose we are consuming, then methanol is not at all poisonous for body. But in our body, methanol is converted into methanol, that is aldehyde. This is formaldehyde. You are aware, in our biology laboratory, various animals we are preserving out into a liquid. We are calling that liquid as formalin. So that formalin is containing formaldehyde. Formaldehyde is very highly poisonous in nature. Just imagine, person consumes methanol, the enzyme in our body will convert methanol into methanol, that is formaldehyde, and poison is generated in the body, and that is the problematic one. Now here ethanol is obviously converted into ethanol, that is acetaldehyde, which is also poisonous for body, but it is less poisonous than methanol. Getting idea? So alcohol is not bad, but in our body there is an enzyme which converts out alcohol into aldehyde. Now see, this enzyme will act on higher molecular weight alcohol first and then lower molecular weight. Basic idea is that. Now person is consuming out that poisonous liquor that is consisting of methanol plus ethanol. As long as ethanol is there in his body, ethanol will converted into acetaldehyde, that is ethanol, and then after converting all ethanol into ethanol, it will start converting out methanol to methanol, and then poisonous impacts start showing. The symptoms of poisonous impacts start showing. This is something problematic. You are getting some clue from my discussion that as long as ethanol is there in body, it will produce only acetaldehyde, which is less poisonous than formaldehyde. Whereas if methanol is there, then it is converted into methanol, which is more poisonous. Suppose you observe such case that many people are troubling out because of this type of poisonous liquor. Obviously, the first role you have to call a doctor. But till that, what you can do, that if there is wine shop or liquor shop, purchase out any branded liquor, usually whiskey or rum, which is branded one. Why I am saying branded? Because it is tested in laboratory, and then ask this fellow to drink that. Why? Because you are inserting out more ethanol in their body. Don't directly mix out in water and then I'll ask them to drink. The reason is that this alcohol is there, it will form ethanol, and till doctor arrive or medical help arrive there, you can stop the formation of methanol in their body and people can save. This is basic idea, that when this type of liquor incidents are there, at that time, if possible, then you can save life of a person. What is use of that? That is different thing. But you can save life of person by giving them more and more ethanol. That means usually liquor that is tested one, and then seek for medical help. So this is simply we can consider first aid for that. This is not ultimate solution. What is rest of the thing, that we had to inactivate that part, that ask him to more and more alcohol, consume more and more alcohol, etc. But that is not our part. our duty is that we have to just give that and wait for medical help. Don't only wait for medical help. Anyway, this is about second functional group we discussed, that is acetaldehyde, that is aldehyde group, which is we are having structurally almost same. Only thing is that here O is one side attached to R and one side attached to H, whereas here O is double bonded with C and not directly attached with H. Now third functional group after R we are discussing, I am writing again R, C, here we have written double bond O, and here in first example of aldehyde we have written H, but instead of that I am writing again OH here. So see the difference, it is OH only, but this OH is attached to carbon which is already bearing 2 oxygen atom. What is the problem of this? Say oxygen is highly electronegative and therefore oxygen is pulling out carbon, electron cloud from carbon, whereas this oxygen is also attached to carbon, try to pull out electron cloud from carbon, and so properties are different here. Now here this group is called as carboxylic, I am not writing entire spelling, carboxylic acid. So here you can find OH group is behaving like acid. Why? We will discuss in inorganic part of chemistry, but here this is called as carboxylic acid. Now R can be replaced by H. So it is HC double bond O, OH. Old name formic acid. So we discussed formaldehyde. Same way this is called as formic acid. So according to our old concept we are calling this as formic acid. In Greek language that formica means red ant. The acid obtained by the formica is called as formic acid. Aldehyde obtained from formic acid, that is called as formaldehyde. So this is called as traditional method of naming, whereas IUPSC name says number of carbon atom, so we are aware it is 1. So 1 means I have to write down methane. Now acid group is attached over here, and so I have to replace E. So I am removing E and adding out word oic, OIC, and name it as acid. So this is I should say oic acid. So whatever is the name, I have to write down the parent alkane, remove end of E, and that is replaced by word oic acid. Now here R is replaced by CH3, C double bond O, OH. So CH3CO, this is in simple word I am writing CH3 COOH, but practically I am writing this way. So CH3C double bond OOH. This is called as acetic acid. Here, according to IUPSC, 2 carbon atoms are there, so I should write ethane. E is there, I have to replace E by OIC. So this is ethanoic acid. So traditional name acetic acid, IUPSC name ethanoic acid. Traditional name formic acid, this is methanoic acid. You are aware this ethanoic acid or whatever the acetic acid that is obtained from fermentation reaction, this is called as vinegar. In French, wine obtained from agar. So something like that meaning is there. You are aware in Chinese food we are consuming vinegar. So that vinegar is 4% dilute acetic acid. So this way we are using this type of acids. Even you are aware this type of carboxylic acids are widely used in our day-to-day food consumption also. Citrus family fruit, that means fruits like lemon, orange, etc. They are called as citrus family fruit. They are containing very good amount of C vitamin. But apart from that, they are containing citric acid also. So this is carboxylic acid. Even I am talking of C vitamin, but chemically it is that C vitamin is called as ascorbic acid. So C vitamin or ascorbic acid, that is present in citrus family fruit. Apart from that, citric acid is also present in citrus family fruit. In buttermilk, we are getting lactic acid. So this way, in general case, we are using this type of organic acids, and you are familiar with this type of compound. So next functional group we discuss, that is carboxylic acid. Now along with this carboxylic acid, now keep in mind, till here I am discussing about nomenclature in IUPSC also, but rest of the thing I am not discussing IUPSC nomenclature. I want to just introduce chemicals. So here this is R, C double bond O, it was OH, but suppose that H is replaced by another R. Maybe this R and this R is same, that here CH3, here CH3, here C2H5, here C2H5. Alright, maybe here CH3 and here C2H5, or vice versa, that can be there. In order, we are marking this as R dash. Meaning is that this R and this R may be same or may not be same. But this type of compound we are calling as ester. So this is acid, now this is called as ester. Esters are having fruity odor and taste. And so whatever essence we are using in beverages as well as artificial essences in fruit, in food, fruit smelling or fruit tasting essences, usually they are of this type of esters. So now you are aware of acid, now you are aware of esters. Now next functional group here, that is R, C double bond O. Now this O is replaced simply, and here we are getting another R dash. So this is similar to aldehyde, but in case of aldehyde here compulsory H is there, whereas here we are getting R dash. Here R dash need not be same as R, but R dash or R I can't replace by H. At both sides there must be carbon atoms only. Then this type we are calling as ketone. The favorite ketone you are aware, that is acetone, usually in nail paint remover, that is made up of acetone. So like that, organic compounds are there. We are discussing now this ketone. Now next functional group, that is also containing oxygen. This is RO R dash. R and R dash may be same or may not be same. Oxygen is there. This type of oxygen RO R dash. R and R dash may be same or may not be same. So this type of functional group is called as ether. So this is ether, but this is not whatever we discuss in physics. That is different. That is the medium which is present in the space. That is different. It is not yet proved, but this is practically present on Earth and one can prepare it easily. This is highly inflammable in nature and volatile also. You are aware of the word volatile now. Volatile means boiling point less than boiling point of water. That is boiling point less than 100 degrees Celsius. We are calling that as volatile liquid. Now here we are getting functional group as RO R dash. Now you are aware about this compound ammonia. In chemical bonding chapter we discussed their structure of ammonia. Now where we are getting NH2 and one H is there, but it is now not there. Then this type of group we are calling as amine. So getting idea, so ammonia, yes, one hydrogen is lost, whatever remaining is there we are calling as amine. So we are calling this as amine. They are primary, secondary and tertiary, but we are not going in detail now. So amine, you are aware of the word amine. Even vitamin, that is also having word amine at end. So these amines are there where nitrogen is present and obviously NH2 group is attached. Now another functional group we are giving Rx. Now here X stands for halogen. You are aware in periodic table we discussed 7th A group, or simply it is called as now 17th group, that is fluorine, chlorine, bromine, iodine. Not astatine we are considering. So fluorine, chlorine, bromine, iodine. These all 4 members we are calling halogen, represented simply by X. So the meaning of X here, that is halogen group, fluorine, chlorine, bromine, iodine is attached, then that is amine, that is halide. So this way we discuss some of the functional group, that is in aliphatic compound. Now we are switching over to aromatic compound. Now in case of aromatic compound, you are aware this is benzene ring, and 6 hydrogen atoms are present at this terminal. Out of that, suppose one H is removed, then whatever is remaining group, that is called as aryl group. So we are representing this as aryl group or aromatic group by letter AR. Now suppose this aryl group is there, that means these all 5 hydrogens are present, 6th hydrogen is absent, that is attached to OH. So this is represented as aromatic or aryl OH. Then this is called as phenol. Try to recollect, we discussed this part, that aromatic group is there and OH. Now this OH is slightly acidic. Again keep in mind, OH is neither acidic or basic or neutral. It depends on the structure which is attached here. So if I am saying phenol, then this is the structure of phenol. Now like that, various acids are also there, aromatic acids. Say for example COOH group is attached over here, we are calling that as benzoic acid, and like that various substances are there, that is categorized under AR. So if AR group is attached, then compound is called as aryl compound or aryl radical. Now keep in mind, this way various functional groups are there. Sometimes they are acting combiningly. Say for example carboxylic acid group at one end and amino group at another end. So combination, we are getting amino acid group, which is fundamental for manufacturing of protein, and protein is body making material in body. So when we are talking of biology, at that time we are discussing this type of biomolecule, particularly peptide linkage and protein synthesis we are discussing at that time. But for that purpose you should aware what is the group, amine group, acid group, phenol group. So we are now discussing about this universe step by step. So first we discuss various units, then certain concepts in physics. Now we are focusing on certain concepts in chemistry, and then we are switching over to knowledge of universe in greater extent. This all whatever we are discussing, that should be considered as fundamental part to get exact knowledge or more knowledge of this universe. So this is the end of topic organic chemistry that is required for our discussion. This is not entire organic chemistry. Organic chemistry is very vast. Whatever nomenclature we discuss, that is just superficial. Whatever functional groups we discuss, they are not all functional group we discuss, but many functional group which are predominantly required for us. Again and again they are required. Only that part we discuss, not entire parts we discuss here. So this is end of our organic chemistry part required for our purpose.